Okay, so let's talk about measures of spread of the data. The main one that we talk about is the standard deviation. And what the standard deviation shows you is how far the data values are from the mean. So it provides a numeric measure for the overall amount of variation in a data set. And it can also show you how close the data values are to the mean. So the standard deviation provides a measurement of the overall variation in the data set. The standard deviation is always positive or zero. The standard deviation is small when the data are all concentrated close to the mean, which means there's not a lot of variation in that data set. If your standard deviation is large, that means your data is spread out more. So you can look at it and determine how your data is. So suppose Rosa and Ben shop at supermarket A. Rosa waits at the checkout counter for 7 minutes and Ben waits for 1 minute. So we're going to use a mean of 5 minutes and a standard deviation of 2. And that standard deviation shows us how spread out the data is. So let's look at Rosa. Remember, my mean is 5 and my standard deviation is 2. So Rosa waits for 7 minutes. And I'm going to compare that to the mean. So 7 minus 5 equals 2. I know that 2 is the same as my standard deviation, so 2 minutes is equal to 1 standard deviation. So Rose's wait time of 7 minutes is 2 minutes longer than the average. So her wait time is 1 standard deviation above the mean. Let's look at Ben. Again, remember the mean is 5 and the standard deviation is 2. Ben's wait time is a minute, so 1 minus 5 gives me negative 4. 1 is 4 minutes less than the average of 5, so 4 minutes is equal to 2 standard deviations. Ben wait time of 1 minute is 4 minutes less than the average of 5 minutes. So that means for 1 minute, he is 2 standard deviations below the average of 5 minutes. I know that sounds really confusing, so I kind of made a table for it. Okay, the mean is 5 and the standard deviation is 2. So here, right here is my mean, okay? Above my mean, 1 standard deviation above the mean is 5 plus 1 times 2. 2 being my standard deviation gives me 7 minutes. 2 standard deviations above the mean is 5 plus 2 standard deviations times 2 gives me 9. But remember, we have 2 standard deviations above the mean, we can have 2 below it. So 1 standard deviation below the mean is 5 minus 1 times 2 gives me 3. That 1's coming because it's 1 standard deviation below the mean. So that gives me 3 minutes. 2 standard deviations below the mean is 5 minus 2 standard deviations times 2, which is the standard deviation, which gives me 1. Basically, that example I just showed you how to do using the standard deviations in the mean. So the data value that is 2 standard deviations from the average, it can be below it or above it, is considered far from the average. So if you look at something that's outside of the 2 standard deviations from the mean, we kind of see that as kind of a data value that we really need to look at because it's not normal. Because in the real world, we say that 95% of the data is going to fall between the 2 standard deviations below the mean and above the mean. So another way we can look at it is we can do the equation value is the mean plus the number of standard deviations times the standard deviation. And that can be done for a sample or a population. I did that in my sample above where I showed the mean was in the middle and the standard deviations above and below it. I did that formula and this is how you write it out. So if x is a number, the difference, x minus the mean, is called a deviation. In a data set, there are many deviations and there are items in the data set. The deviations are used to calculate the standard deviations. So a number belonging to a population in a symbol, a deviation is x minus the mean. And for sample data, the symbol is x minus the mean again. So here's the formula for a sample standard deviation and a population standard deviation. Do not do this by hand. Your calculator will do this for you and you don't even have to worry about it. The one thing you do want to notice is in a sample, If you go here, you're doing the sample size minus 1. In a population, we don't account for that, and we only just give the sample size of the population or the population size. Sample variance, if you went back and looked, sample standard deviation was noted by an S. Sample variance is noted by S squared. And then population variance is noted by sigma squared. Okay, we're going to look at this in the calculator in just a second. Your concentration should be on whether the standard deviation tells you about the data. The sample standard deviation is a number that measures how far the data is spread from the mean. So your standard deviation can be 0 or larger than 0. If your standard deviation is 0, there's no spread. That means everything is equal to each other. If your standard deviation is small, that means most of your numbers are near your mean. If they're large, they're away from your mean. Okay, so let's do this. I'm going to bring up the calculator, okay? This is the data set we've been using. Okay, so I'm going to go ahead and turn my calculator on, and I'm going to go in. Oh, first thing I'm going to do is I'm going to clear out my data. So I do second plus list and enter. Okay, so now what I'm going to do, I'm going to stats, I'm going to hit edit. So then I'm going to put 18. I'm going to do 18 again. I'm going to put all this data in there. 17. I'm going to do 16. I'm going to do 19. 24. 22. 37. 19. 21. 20. And then 18. Okay. Oops. So I have my data in there, and then I go to stat again, and I go to calculate, and then I hit enter, and hit enter again. Okay, remember my mean was 20.75. I'm not worried about that now. I'm going to skip the summation of x and the summation of x squared. I'm going to go here to SX. This means sample standard deviation. For this problem, my sample standard deviation is 5.5779, and I'm going to probably round it just to 5.6. The next one is my population standard deviation, which is 5.34. So for this one, it would be 5.3. To get my variance, then what I need to do is I need to square my sample standard deviation to get my sample variance. And to get my population variance, I just need to square this number. And what you do is you write this number down, then you go back to your main screen. So let me do this. Let me do 5.58 is my sample standard deviation. So I'm going to click here. I'm going to go clear, and then I'm going to do I'm going to do parentheses. Let me go back and do parentheses. 5.58. Close the parentheses, and then square it, and that gives me my sample variance. That's how you do that. Okay, so let me keep going back to the PowerPoint. Okay, so we saw how to do that. So right here, if I said my sample standard deviation was 5.577 or 5.6, all I need to do is square that to get that value. I was off on the calculator because I put 5.8. So it was close. So I was good. Okay. And then for the population standard deviation, I got it was 5.34. And if I square that, I get 28.09. It's going to ask you if it's a sample or a population. You just choose which one. Okay. And again, right here, I have the directions for finding the standard deviation or variance of a group frequency tables. Again, that's the one where you find the midpoints and then you put everything in. Okay, so now comparing values from different data sets, we use something called the z-score, and that's a value minus the mean over the standard deviation. And we can write this a couple of different ways. Let's look at data sets for samples. So I can do If I'm finding my data value, then what I'm going to do is I'm going to put my mean plus my z-score times my standard deviation. That's if it wants to know the actual data value of something when you have the mean and the z-score and the standard deviation. If it asks for the z-score, you're going to put the data value minus the mean divided by the sample standard deviation. It could ask you which ways to do this. This formula right here is the same as this, okay? So we'll keep going. And I can also do it for populations. This is basically the same thing I had on the other screen. I just wanted to use the terms better. So data value minus the mean plus z times the standard deviation. And then I have z minus the data value minus the mean over the standard deviation. Okay, these are the way that you can do the problems in the book.